Hi all, good morning. Kindly confirm the audio and the video. All students who are listening to me, kindly confirm the audio. Good morning to all. I hope I'm visible. So we meet for another class on geography. I hope you're keeping good health. Air quality is definitely taking a toll on the health of many people. Delhi, wind is 3 kilometer per hour. Okay, that's not what we're looking at. Doesn't look that good. Think this is the one we were looking for. Koderma, Jharkhand, all good. So the Supreme Court is also monitoring the quality in the North Indian plains, especially Delhi. Delhi has recorded the highest polluted levels, and India, of late, I was looking at India is the most polluted one as of now. The air quality, in sense of air quality, the average air quality of India is one of the highest that is operating right now. Okay, so Banaras 30. So the temperatures are or should have gone down by now. Banaras, the temperature range is 18 degrees Celsius. Anyone from the coastal areas? Pune also 17 degrees Celsius. I'm looking at the diurnal range. I'm looking at the diurnal range. Varanasi is 309. Prayagraj AQI 97. इतना अच्छा चल रहा है क्या? Jalandhar 410. How come Banaras is 309 and Prayagraj is suddenly 97? एकदम ही मतलब अमृतकाल हो गया उधर तो. एवरेज से भी नीचे. Yeah, I'm looking for a coastal location. Anyone from the coastal location? Audible and visible. Darbhanga, the range is 12. That's not a coastal location. I'm looking for a coastal location. So Faridabad, severe zone schools have been closed. Yeah, NCR schools have been closed. Online schools are running. Banaras 189. Darbhanga is this. Yeah, Prayagraj now AQI is 128. No, I'm not looking for diurnal range of any inland location. I'm looking for coastal locations because I can see 15 to 17 is the diurnal range for inland locations. I'm looking at the range for coastal locations. Patna is 15. That will be, it will be around 15, 17. 12 to 17 will be the range. Actually, if anyone, do give me the data that you have. So I was also a little down with because of the weather. Again, certain allergies and other things triggered. So I'll try and keep the class alive and energetic. I'm requiring your cooperation also in this. So just in case I feel a little low, let's keep the josh high. Okay, coastal location. If you have something, do give me this. So humidity पे हमने बहुत बात कर लिया था. Everyone, we had talked a lot about humidity. Any questions on humidity? Because now we are going to go into precipitation. I had given you some homework also. So maximum relative humidity, where it is happening, because they've asked us. Your question was, what are the types of precipitation? What are the forms of precipitation? And the process of precipitation. That's what we are going to talk about. Types, forms. That is what we are going to talk about. ये होमवर्क हुआ है कि नहीं हुआ, जल्दी से बताओ. टाइप्स ऑफ ह्यूमिडिटी इज डन. टाइप्स ऑफ प्रेसिपिटेशन, फॉर्म्स ऑफ प्रेसिपिटेशन. दिस इज व्हाट आई हैड रिक्वेस्टेड. ओके, वेदर रिपोर्ट डन. ये किया है कि नहीं किया, ये मैं पूछ रहा हूँ. कुछ होमवर्क दिया था अबाउट प्रेसिपिटेशन, बी इट एनसीईआरटी, बी इट केजीएस बुकलेट, और बी इट Savin Singh. I had someone in the offline batch. He told me he's done that, but I thought of asking the whole batch quickly. Okay. So there are three and only three types of precipitation. Number one is the convectional rain or precipitation. Number two is the orographic precipitation. And number three is the frontal precipitation. एनसीईआरटी ने शायद इसका कुछ और नाम दिया है. ये सुनो, एनसीईआरटी may have given it a separate name. That's what we are talking about. Is everyone with me on this? That's what we are talking about. So when we are talking about convectional rain, there will be a science to it. There will be a science to it. There will be a geography to it. So what are we interested in? We are interested in the geography to it. Science तो थोड़ा बहुत आएगा. We would get to know. So convection is due to heat, convectional rising of air followed by adiabatic cooling and condensation. We must learn to write the whole thing, not the Savindra Singh way, which is, unnecessarily too much of elaboration. Straight away, what is this? There is heat. Because of heat, what will happen? The air will become lighter than its surrounding. It will start to rise. Convection, we've already talked about that. And as the air rises, it will cool. The air parcel will expand because the pressure around it is not that much. And as a result, what will happen? Adiabatic cooling will happen, condensation will happen moment the dew point is reached. You should also be in a position to draw this diagram. So you have the surface. The surface is at 40 degrees Celsius. It is warm over here. It is warm over here. So what happens? Your air parcels your air parcel begins to rise. Yes, this is what convection happening. Now, as the air parcel is rising, it is growing bigger, 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 and it grows bigger. But it is cooling also. As it is rising, adiabatic cooling, and here, by the time it reaches here, it has turned into clouds. Is everyone okay? This is what your diagram would be, that due to heat, convectional rising of air happens, air parcel rises, it expands, adiabatic cooling happens, condensation happens, and that's what we are talking about. Maybe a temperature comes where the dew point is reached. Dew point may be 5 degrees Celsius. Just an example, and then clouds are created. Get that? This type of precipitation is there. Now the bigger question that we must be interested in is, which areas of the world? But that's geography, not the diagram. Which areas of the world? So first is, when we are talking about this, first would be what? The equatorial regions. Equatorial belt. Second is tropical and subtropical belt. Geographical idea. Where in the world would it be? So equatorial region, tropical and subtropical regions, and one very important things, more in summer and maritime belt. Please look at this. What have I added? It's very simple to think of. It's very simple to think of the latitudes which have the heat. But then apart from heat, we need the moisture also. So where is more heat? Which season is it more? More in summers. Summers. And if you have a closure to, if your proximity to the oceans is there, you will have more moisture. Is everyone clear on this? Irrespective of whatever we are talking about, the convection process takes place at many places, and we are talking about this. Is everyone with me on this? Any questions on this? Please ask. This is a quick recap of what you generally do in GS also. Orographic precipitation and frontal precipitation, both of them are called barrier precipitation. Yes. And orographic or mountainous barrier forces a moisture laden wind to rise, cool and condense. Here the same thing. A frontal zone forces a moist, warm air mass to rise, cool and condense. That's all we are talking about. Almost the same. So here the air was rising on its own. The air is buoyant. B-U-Y-O-A-N-T. Buoyant, warm air. But there the air need not be buoyant. The air is heavy, but there is something causing the air to rise up. Remember, we were talking about stability and instability. I told you when a parcel is forced to rise, it has a tendency to continue to rise in an unstable atmosphere, and it has a tendency to fall back in a stable atmosphere. But who was causing it to rise? Is everyone clear about this? When you ask types of precipitation, be precise. You don't have to write too much. Write one sentence. Learn to say things in one sentence and then show it on a diagram. So this diagram, I often make this diagram, that this is a coastal area. From the coastal area, we have the moisture laden winds. Moisture laden winds are coming. So what should they be? Onshore. Onshore moisture laden. That should be one. Second thing should be orographic barrier. It can be a mountain, it can also be a plateau. And this causes the air to rise. The air will be forced to rise and cool and condense, and it will create a lot of rain. However, on the other side, the opposite will happen. Adiabatic compression. On this side, it was adiabatic expansion. On this side, it was adiabatic expansion. So people who are not able to read it, I am speaking it out. I am speaking it out. Is everyone okay? Do we get that? Is everyone okay? Everyone clear? Now there is this student Sagar Sonkusare. He's saying, but in subtropical there is sinking air with clear sky. So Sagar, I hope you will use the right brain also. You would not be that mechanical in your thinking, not that narrow in your thinking. So we have a state of Rajasthan in India, which lies in this belt. Yes, subtropical belt. And because the air is sinking over here, there is a desert in it. But does rain happen in Rajasthan? Definitely less. But does rain happen in Rajasthan? If rain is happening in Rajasthan, then what rain is that? What rain is that? So there is heat, there is moisture, there is heat and there is moisture that is rising, evaporating and then condensing. Do we get that? That's what I'm talking about. Excuse me. So that's what we are talking about, everyone. Did we understand? तो सिर्फ बात के लिए बात नहीं निकालते. We did not say that it is the subtropical high pressure belt. We just said tropical and the subtropical belt, where the conditions, if favorable, if the temperature is there, if moisture is there, what will happen? The air will rise. It is buoyant. Are we clear? So इस साइड क्या होगा? इस साइड hot and dry. This side will be called the rain shadow region, and this will be the rainy region. This is the windward side. So rain on windward side. Rain shadow on leeward side. Is everyone okay? तो ये हो गया आपका ओरोग्राफिक प्रेसिपिटेशन. This is your orographic precipitation. Let's have a look at this. So we are talking about this solar heating. It can happen in the subtropical belt also. It can happen in Dubai also. Dubai mein bhi barish hui. Yes or no? It can happen in those desert belt also. Evaporation is there. The only problem with the desert is moisture is not there. But if there is some local source of moisture, suppose there is a lake or something, what will happen? It will evaporate, rising air because of thermal reasons. It will rise and it will condense. So, localized convective lifting is in which unequal surface heating causes localized pockets of air to rise because of their buoyancy. And definitely the rain that will be associated with equatorial region or the normal tropical belt compared to the subtropical belt would be less. Yes or no? जहाँ ज़्यादा होगी, जहाँ moisture ज़्यादा होगा, that is going to be there. Is everyone okay with the first one? First one, this is the diagram which we have. The second diagram is orographic lifting. Three mechanisms cause air to rise. Okay. The first we have already talked about. The first, when we were talking about, first is already talked about, in which the air is buoyant, so it is rising. Second mechanism is your orographic lifting. So this is the air which is coming, whatever may be the rain. This is the windward side. It rises, rains. This is the rain shadow side. Is everyone clear about this? The second part. Now we are coming to the third part. Can you see this? This is cold air. This is cold air. This is warm air. This air and the warm air, when they are coming and colliding with each other, what is happening? They are coming and colliding with each other. So warm air was coming this side, and cold air, which has a tendency to be heavy, dense, you can see is coming this side. When they collide, so this is the boundary, the warm air cannot push the cold air, and cold air wants to stay close to the ground. So warm air, you will see, will rise up, will be forced to rise up. When it rises, it cools and condenses. When it rises, it cools and condenses to create the cloud. Now again, the question is, everyone please pay attention, the question is that there is a barrier. Which is the barrier here? Mountain was a barrier. Yes or no? This was the barrier. Here also we have a barrier. And what is this barrier called as? Front. This barrier is called the front. Is everyone clear? Everyone clear? Frontal, and this has different names. It can be called frontal lifting, it can be called frontal wedging, in which the warmer, less dense air is forced over the cooler, denser air to rise up. It's like we put suppose there is a car is parked somewhere and there is slope, so that the car does not roll back. Do we put some stone next to the wheel of the car? Yes or no? So that it does not roll back. It's like a wedge. So उसी तरह से what is happening is this cold air has wedged next to the warm air, and this is called the frontal wedging. Word है, term है. That is why I am using it, because the examiner may use such terms. That's why I am trying to bring that to you. Everyone with me on this? So three types of it have we written it. Where will frontal wedging be located? That's my question. सबका हमने एरिया देख लिया. Where would it be located? That's my big question. My big question today is the first one we talked about. ये कहां पर होगा? जहां पर भी onshore moisture laden wind है and orographic barrier. So this does not have any latitude. So the geographical part of this, where in the world will it be? It will be in these areas. Where will this be? So I haven't drawn the diagram. So just in case you're looking for the diagram, so here will be the cold air. We will look at the cold air. The cold air would be heavier. And the warm air warm air will be forced to rise up, and as it rises, it cools adiabatically and it creates clouds. When I'm doing fronts with you, I'll be talking about that. So everyone is saying, sir, this happens at the subpolar low pressure. See, subpolar low pressure kahan banta hai? That is the question now. Subpolar low pressure, where is it created? ये तो आपका डायग्राम हो गया. आई होप यू विल यूज दिस डायग्राम. इस डायग्राम को सब पोलर लो प्रेशर कहाँ बनता है, व्हाट इज द एड्रेस ऑफ सब पोलर लो प्रेशर. इसका तो मैंने आपको एड्रेस बता दिया. व्हाट इज द एड्रेस ऑफ सब पोलर लो प्रेशर एवरीवन? 60 degrees north and south. Yes, that is what I am looking at. So it is not 60 degrees north and south. Remember that belts keeps on shifting. So the answer is geographically it is the mid latitude belt. Do we get that? Generally you will find it from 40 to 65 degrees north and south. So all the students who are writing it as 65 or 60 degrees, that is my very precise thing to all of you. First of all, the belt is never a line. Have we already talked about that or not? The belt is never a line. Belt itself is a 10 degree thing. So 30 से नीचे 40 आ जाएगा आपका, 40 आएगा, और ऊपर क्या चला जाएगा, सॉरी 60 के नीचे क्या आ जाएगा आपका, 50 आएगा, एंड ऊपर भी जाएगा कुछ. यस. एंड कैन दिस बेल्ट शिफ्ट ऑल्सो with what? With latitude. It can even come up to 30. Mid latitude belt. Actually, mid latitude belt is what? 30 to 60. So entire mid latitude belt. So I hope you will not be so narrow in your understanding कि आंसर लिख रहा है 60 डिग्री पर होता है. Do you know that India will be receiving in 2 months from now, January onwards, we will December, January में ही आ जाएगा. We will start getting western disturbances. Western disturbances will start impacting northern states of India and the Union Territory of Jammu and Kashmir. So where will it come from? Where will it come from? It will be that these frontal systems which will be coming to India. इंडिया का लैटिट्यूड कितना जाएगा मैक्सिमम? 35 40. ये सुनो, वही 35 में ही खत्म हो जाएगा वो, जब हम बात कर रहे. वी आर टॉकिंग अबाउट जब हम कश्मीर की बात करते हैं. ये सुनो. सो व्हाट इज द मैक्सिमम लैटिट्यूड वी गो? 37 जाते कि नहीं जाते? 8 to 37. सो इंडिया में भी आएगा फ्रंटल वेदर. हाउ विल इट कम? थिंक अबाउट इट. सो इफ यू आर नॉट एबल टू प्रैक्टिकली रिलेट टू इट, तब सबके सब आंसर क्या लिख रहे हैं? 60 डिग्री पर आएगा. इट इज नॉट 60 डिग्री. द बेल्ट विल चेंज. Everyone with me on this? If any questions, please ask. The seasonal shift of the belt will also happen. So 3 types of precipitation. That's our first topic of the day. Types of precipitation. The 3 types. The second is this and third is this. फॉर्म ले ले. चलो फॉर्म लेते हैं. फॉर्म्स ऑफ what forms precipitation is going to take. That is what we call as the forms of precipitation. तो जल्दी से बताओ, what have you read from the book? What are the various forms of precipitation? What are the various forms of precipitation? Though I would be changing it in many other things also. So quickly, what are the forms of precipitation? What are the different forms of precipitation? Rain, snow, drizzle. Okay. So form is the physical form taken. पहले तो ये समझना चाहिए ना. Precipitation is falling from the sky. So that's the form. So when people say, like sleet, frost, snowfall, rainfall, as an optional student, we should be able to do that. Is everyone okay? So form of precipitation when we are talking about. So first we will look at the liquid ones. In liquid, I have rain and drizzle. In liquid, I have rain and drizzle. And how do I differentiate between them? Size of droplet in terms of its diameter. In terms of its diameter. So what is our experience? Our experience is that rain is something which is heavy or bigger drops, and drizzle is something which is lighter and smaller drops. So yes, we would keep that. 0.5 millimeter to 5.0 millimeter is the size of a raindrop. So this is a large drop, and this is a small drop. If the size is 0.05 to 0.5 millimeter, then we call it, the thing is called as drizzle. Is everyone okay? So ये याद रखना है, पहली चीज तो ये. A question which I have now is what about drops which are bigger than 5 millimeter? Quickly, common sense question. What about drops which are above 5 millimeter? What about drops which are above 5 millimeter? ये क्लाउड है. क्लाउड से a drop is falling down. A drop is falling down. What about sizes more than 5 millimeter? Quickly, yes or no? So if I wait for your answer, उसमें बहुत देर लग जाएगी. तो the drop when it is falling, everyone, the drop never has this shape. ये जो आपकी शेप है ना, ये आइडियली शेप जो ऐसा हो रहा होता है, ऐसा होता नहीं. What is happening is, वो देखो नीतीश कह रहा है ड्रॉप मोर देन 5 इज कॉल्ड स्नो. नीतीश तुम्हें कुछ नहीं पता है, पढ़ लो, कोई बात नहीं. ऐसे वाले जवाब भी देने थे तो भाई टीचर का पूरा हेल्थ ही उड़ जाएगी. ये पता चल गया नीतीश कोई किताब विताब तुम पढ़ते नहीं हो. बाकी लोगों के लिए जो कॉमन सेंस यूज करते हैं, नीतीश की मैं बात नहीं कर रहा हूं. स्नो इज नॉट लिक्विड. वैष्णवी, स्नो इज नॉट लिक्विड. तो ये क्या होगा यहां पर, व्हेन द ड्रॉप इज फॉलिंग, इज देयर एनी रेजिस्टेंस और नॉट? ये रेजिस्टेंस किसका है जल्दी बताओ. हु इज रेजिस्टिंग? हेल भी बिटिया सॉलिड होता है. हेल भी सॉलिड होता है. दिस इज अपड्राफ्ट ऑफ एयर. और ये फ्रिक्शन भी होगा ना, फ्रिक्शन भी होगा. So imagine you would have seen people with like on bike at a high speed. तो उनके face में like because of हवा के pressure से चीजें change हो जाती. So this drop when it is falling, it changes the shape. So the drop actually takes this shape. समझ में आया? And because of the friction, it cannot stay like this. ये हवा इसको तोड़ देगी. So this will turn into what? This will then turn into, ये जो आपका ड्रॉप था, this drop of water will take this stage, and then what will happen? It will turn into 3 separate drops. So it is not easy for water to be more than 5 millimeter in dia. More than 5, what will happen? It will break. More than 5 millimeter, drop will break. Is everyone okay? कॉमन सेंस की बात करता हूं, वो तुम लोग लगाते नहीं हो, ठीक है? अगर इससे भी छोटा हो गया, 0.5 मिलीमीटर से अगर छोटा हो गया, तो वी कॉल इट मिस्ट. वी कॉल दिस एज मिस्ट एंड फॉग. 5 मिलीमीटर से बड़ा क्यों नहीं हो सकता? इट विल ब्रेक. इज एवरीवन ओके? बिकॉज द ड्रॉप इज फॉलिंग, नीचे से ऊपर फ्रिक्शन है, एंड द अपड्राफ्ट ऑफ द एयर इज ऑल्सो देयर, फ्रिक्शन इज ऑल्सो देयर, एटमोस्फेरिक एयर, नो? सो 5 मिलीमीटर से बड़ा हो नहीं सकता है. 0.5 to 0.05 to 0.5 इट इज कॉल्ड मिस्ट, सॉरी ड्रिजल. आई एम श्योर सभी लोगों ने ड्रिजल देखा है कि नहीं? रेन तो बारिश होती है, ड्रिजल क्या होती है? बूंदाबांदी. ड्रिजल क्या है? बूंदाबांदी, हल्की बूंदे जो पड़ रही हैं, दैट इज दैट. देन वी कम टू मिस्ट एंड फॉग. अगर 0.05 से नीचे है तो वो क्या हो गया? मिस्ट हो गया, एंड देन फॉग इज देयर. अब मिस्ट एंड फॉग के पार्टिकल साइजेस क्या है? मिस्ट एंड फॉग के पार्टिकल साइजेस कुछ नहीं है, इफ इट इज अ फंक्शन ऑफ विजिबिलिटी. If it is more than, if it is restricted or reduced, but more than 1 kilometer, then it is mist. If the visibility is restricted or reduced, but less than 1 kilometer, that is called mist and fog. Is everyone okay with this? So can I say, in a way, fog is a more dense form of mist. Is everyone okay? And they, along with the third one, is, what do we have, is dew. What is dew? ये भी हो गया, ये भी हो गया. This is done. What is dew? What is dew? Water near surface condensing at temperature below dew point. Yes or no? अब ये तीनों को, something which I want to write here. Not considered as forms of precipitation. Not considered as forms of precipitation. Is everyone with me on this? Now, whatever I had to write, whatever I had to draw about forms of precipitation, particularly first the liquid ones. I have done it. I have done it. Now, I also raised the question on sizes. So rain and drizzle are based on the size of the water droplet. Fog and mist are based on the visibility criteria, and dew happens on suitable surfaces when the temperature is close to close to the dew point. The thing has cooled over there. Is everyone with me on this? With me on this, everyone? तो ये तो हुआ आपका पहला चीज. Why don't we consider mist, fog, and dew as forms of precipitation? Quickly, everyone. Why don't we consider them as forms of precipitation? They are not considered forms of precipitation because they are not falling from the sky. They are created there itself. In fact, fog and mist is like a low level cloud. Is everyone okay with this? So, this is one thing. Now, here I also want to talk about two things. First is the hygroscopic nuclei. Hygroscopic nuclei. Suitable surfaces upon which atmospheric moisture may condense when air is cooled below dew point. That is called a hygroscopic nuclei. For water to condense, it is an essential requirement. For water to condense, it is an essential requirement. It is an essential requirement that for water to condense, everyone, it is an essential requirement that hygroscopic nuclei should be there. If the air is clean, there are no hygroscopic nuclei. Will the rain or liquid drop formation happen or not? That's my question. So कुछ hygroscopic nuclei जो आपने पढ़े हों, hygroscopic nuclei, also known as condensation nuclei, are a must, are a prerequisite for water vapor to condense. So this can be, what are these hygroscopic nuclei? Dust, ash, soot, sea salt, suspended particulate matter. They can also be, what do we have? Pollen grains. Pollen grains. Dust, ash, soot, sea salt, suspended particulate matters, pollen grains. यही वाला है? Yes. Can they also be human induced? Can they also be human induced particles or pollutants? Can I say that? हो सकते, क्या हम कर सकते? Can we do it? So that's your hygroscopic nuclei. Hygroscopic nuclei are a must for condensation to happen. So everyone, please get certain points over here. Number one, condensation happens below dew point temperature or saturation point. So condensation कब होगा? Condensation कब होगा? जब air is happens in air cooled below dew point temperature. Is everyone okay? आपको बताना चाहता हूं थोड़ा सा साइंस, a little bit of science, little bit of science. This is water. This is water. What is the pressure on the water surface at any given time? What is the pressure on water surface? At any given time, what is the pressure on water surface? What is the pressure on water surface? Atmospheric pressure. Yes or no? So it is the atmospheric pressure. Now water has got water. Water is in the liquid state. Yes. If I am heating it, some of this water, everyone please pay attention, some of this water wants to evaporate. Some of this water droplet want to evaporate because water can turn into solid liquid gas, wants to rise up. Why is it not evaporating? Why is it not evaporating? Atmospheric pressure is pressing on it, not allowing water to turn into vapor. Is everyone with me on this? But if I heat this surface, if I start giving heat to this surface using a burner, if I heat this, what will happen? Will energy go inside or not? Will these particles also have energy? Yes or no? Will they also develop their pressure? Will they also develop their pressure? They also developed their pressure. This is called vapor pressure. Is everyone okay? So the fight is between which two pressures? Right now there is a fight. There is a fight between two pressures. Can you tell me where is the fight? दो प्रेशर्स के बीच में फाइट चल रही है, जल्दी से बताइए कहां हो रही है? So it is between the atmospheric pressure and the vapor pressure. If I keep on giving heat, will the vapor pressure increase? Yes or no? Can a point come that vapor pressure is equal to atmospheric pressure? Students with science background, please tell me, what is that temperature called? Temperature at which vapor pressure will become equal to atmospheric pressure. At boiling point vapor pressure is equal to atmospheric pressure. Is everyone okay? Science थोड़ा सा याद दिलाया मैंने. So for air to boil, air to turn into vapor, if I add more energy, what will happen? Boiling will cause gradually the water to keep on changing into vapor, and entire water can be evaporated. Do we get that? But keep in mind, evaporation happens at all temperatures, not just boiling. So we don't have to wait for the water to boil to evaporation to happen. बस ये होगा कि वेपर प्रेशर कम होगा तो थोड़ा थोड़ा इवेपोरेट हो रहा है. Yes or no? The amount of evaporation at any given temperature would be a function of its temperature. If the temperature is low, low evaporation. If the temperature is high, high evaporation. Maximum evaporation after boiling pressure. Is everyone, did you understand boiling? Because boiling is easy to understand. Boiling is easy to understand. Evaporation, is everyone okay with this? Is everyone okay with this? Is everyone okay with a little bit of this word used as vapor pressure? So whenever we are looking at boiling and evaporation, we talk in terms of vapor pressure, that the vapor pressure on the surface of the water, if the temperature is high, is higher and it will fight the atmospheric pressure and it can change the state. Perfect. Very good. Thank you. And evaporation happens at all temperature. At boiling, after boiling तो फिर maximum है. After boiling, whatever heat you are giving, because now your vapor pressure will be more than atmospheric pressure. अब आप पूरा का पूरा vapor में turn हो जाओगे. Am I talking about evaporation today? Is precipitation about evaporation or it is the opposite of that? It is the opposite of that. It is about vapor turning back to liquid. So boiling requires rise in temperature. What will precipitation require? Sir, precipitation requires cooling. Is everyone okay? Precipitation requires cooling. Yes or no? Precipitation requires cooling. Yes. And precipitation requires increase of vapor pressure, reducing the vapor pressure. For condensation, what do you want? For condensation to happen, pressure बढ़ाना है vapor का या कम करना है? Sir, vapor pressure must reduce. Yes, this will happen. This happens when air is cooled. When air is cooled, so cooling leads to condensation. Yes. At dew point, if cooled to dew point means all vapor has turned into liquid, saturation occurs. And here what do we call it? RH is equal to 100% saturated air. Is everyone okay? And just like I wrote, evaporation happens at all temperatures. Condensation begins even before dew point is reached. Everyone okay? These are basic science things which I am talking about. So for precipitation to happen, I require cooling, I require vapor pressure, I require all these things, but there is a very, very important things which we have not written. Plus hygroscopic nuclei. Did you understand my intention behind doing what I have done here? तो हाइग्रोस्कोपिक न्यूक्लियाई को इज्जत देना बहुत ज्यादा जरूरी है, उसके बिना काम नहीं बनेगा. Everyone with me on this? Everyone with me on this? So this is what we are talking about is hygroscopic nuclei. This is what we are talking about condensation. Did you understand about vapor pressure and other things also? अगर आपने किताब में पढ़ा, कोई confusion था, so I've deliberately used the word vapor pressure. Vapor pressure is the pressure created by the vapors, and it is against the atmospheric pressure. So if the vapor pressure is on the high side, chances are that it will turn into vapor. Yes, that's the boiling side. If the vapor pressure is low, then it has a tendency to turn into liquid. Is everyone okay? One more thing which I want to add. For freezing to happen, for freezing to happen, उधर भी चाहिए, freezing nuclei are needed. For condensation to happen, what do I need? Condensation nuclei. For freezing to happen, there also I will need something, and they will be called as your freezing nuclei. Is everyone with me on this? We were talking about rain and drizzle. When will rain and drizzle form? When the air is cooled, below its dew point or saturation point, and there are sufficient nuclei for that to happen. With me, everyone? Okay. Now let us talk about solid forms of precipitation. Solid forms of precipitation. सबसे इंपॉर्टेंट है आइस क्रिस्टल. It's very light floats in air. Yes, ice crystals combine to form स्नो. तो जिसे आप स्नो कहते हैं वो किससे बनती है? मेनी आइस क्रिस्टल्स कंबाइन टू फॉर्म स्नो. Is everyone okay? So first is always ice. Ice is your this thing. ठीक है? So can I say these are enlarged ice crystals? So हमेशा पहली चीज that should come to your mind is ice crystals. So people who have seen snowfall, you've actually seen those crystals falling on you. These are very, very light. They stay freely suspended, float in air or freely suspended. जैसे आपका मिस्ट और फॉग होता है, mist or fog stays suspended. Similarly, snow also, ice crystal stays suspended, and when it becomes bigger, then that is there. We've also heard of sleet, rain plus frozen rain drop. Sleet does not have crystals. Sleet is actually the drop getting frozen. And here we have the hailstone, yani ola. Yes. Uh, Under unstable atmospheric condition, repeated melting and freeze cycle create ice pellets with concentric ice layers. So कैसा होगा hailstone? Hailstone will have concentric layers. So concentric layers कैसा होगा? There is this layer. Around the next one we have, this is the second layer. Then we have the third layer. Then we have the fourth layer. So if you cut open a hailstone, it will not be one drop frozen. Just that happens in sleet. Sleet में क्या होगा? One drop is frozen. But in hailstone, what is happening is there are layers of this is what a hailstone is like. Repeated freezing, thawing, and happens in highly unstable air. Everyone with me on this? Happens in highly unstable air. Done, everyone? इनको फोटो में देख ले एक बार. Drizzle 0.5 mm, I told you 0.05 to 0.5 mm. Then 0.5 to 5.0. Sleet is also there, but sleet is solid. It is the raindrop, that is why the size remains that. Freezing rain layers, we call it the glaze. So ये भी उसी का category है. Sometimes it is like a layer on the surface, frozen air. Snow is 1 millimeter to 2 centimeter. Hail is 5 centimeter or larger. Hail is 5 centimeter, 5 to 10 centimeter, 1 millimeter to 2 centimeter. हमने इसको क्या किया? 1 millimeter to 2 centimeter. That is the dia over here. And hailstorm का हमने क्या किया? 5 to 10 centimeter. Again, these are the average sizes. The biggest that we have seen a hailstone falling is almost the size of a 1 kg sugar bag. So that's what has happened. So these are your forms of precipitation. Is everyone okay? Forms of precipitation, they will fall out of the sky. So that is what we are talking about. Sleet is okay. If you want, you can add glaze and rime in your answer. Not needed, but in case you want that, glaze and rime are visual accumulation of this thing and they are solid. So that is why I have written this. But हमें answer में इतना लिख देना है, तो दैट इज बेटर दैट वी हैव. अदर्स में डाल के अदर्स, glaze and rhyme. Everyone okay? So this is one thing which I wanted to talk about. Next thing I want to talk about is the clouds. We've talked about this. So we're talking about precipitation, types of precipitation, forms of precipitation, cloud, and process of precipitation. Clouds and process of precipitation. So what is cloud made up of? पहला तो ये देखना है. What is cloud? Clouds are freely suspended water droplets and water droplets and ice crystals freely suspended water droplets and ice crystals created due to cooling and cooling, condensation and freezing. Cooling, condensation and freezing of water vapor in atmosphere. So we're talking about clouds, and we'll also understand the process of the process of cloud से precipitation कैसे होता है. Everyone okay with this? So first is water droplets are there. They are made up of water droplet. They are made up of ice crystals. दो चीजों से cloud बनता है. If this is the cloud, suppose this is the cloud, what will it have? It will have these tiny little droplets with a few ice crystals. Is everyone okay? Water droplets. The cloud droplets too tiny, buoyant, and maybe dia around 10 micrometer. 10 micrometer. I'm just giving you the size of a droplet. कितना होगा? Around 10 micrometer होगा. So the hair, if I look at the diameter of my hair, body hair, that will be around 70 micrometer. 60, 70 micrometer. So can you imagine, this drop is too tiny. The strand of your hair का भी 1/7 करिए. You reduce it to 1/7 and that's there. So it remains freely suspended. What does it require? It requires for this droplet to form cooling plus condensation nuclei. Cooling plus condensation nuclei. Yes? If the cooling happens to dew point, dew point plus condensation nuclei is there, cloud will form. Is everyone okay? In this, if cooling happens below 0 degree Celsius, yes, and condensation nuclei, so this is cooling dew point, this is called saturated air. If cooling happens below 0 degree Celsius and condensation nuclei are not present, what will that condition be called as? In this what will happen? Cloud droplets will not form. Yes, air will be super saturated or super cooled. Is everyone okay? So the air, water may not condense or freeze. Water may not condense or freeze. Super saturated or super cooled हो सकता है. Yes or no? May not condense or freeze up to minus 40 degrees Celsius if the nuclei are not present. So I need those nuclei. I hope you realize the importance of those nuclei. Is everyone with me on this? Everyone, are we clear on this? So that is clouds. Not every cloud generates precipitation. That is another aspect. And the final aspect which I want to write here is clouds have been classified on basis of their shape and altitude. क्लाउड्स को शेप और ऑल्टीट्यूड पे क्लासिफाई भी किया गया. एवरीवन, डू वी अंडरस्टैंड समथिंग अबाउट क्लाउड्स? थोड़ा बहुत क्लाउड्स का, ये जीएस में उस लेवल की बात नहीं करते. वी टॉकिंग फॉर ऑप्शनल स्टूडेंट्स, सो दैट इज व्हाई आई एम टॉकिंग अबाउट दिस. इज एवरीवन क्लियर अबाउट दिस? टॉकिंग अबाउट क्लाउड्स. Okay, now let us look at this then. Cloud classification. And I'm not going to talk much about this except for in the diagram based on height. High, middle, low clouds. High is more than 6 kilometers, middle is 2 to 6 kilometer height, and low cloud is less than 2 kilometer high. That based on shape. Based on shape, layered clouds are called as stratus cloud. Layered clouds. Layered clouds. Yes. Cumulus these are in the form of layered नहीं है, these are in the form of clusters. कॉटन बॉल शेप्ड या कॉटन, क्या बोलूं इसको, कॉटन नहीं, कॉलीफ्लावर, कॉलीफ्लावर शेप्ड, ठीक है. और थर्ड इज सिरस, फाइब्रस स्ट्रैंड. हाई के लिए हम यूज करते हैं, वी कॉल इट सीरो क्लाउड्स. मिडिल को हम सिग्निफाई करते ऑल्टो से, और लो क्राउड को हम सिग्निफाई करते हैं स्ट्रैटो से, बेस्ड ऑन शेप ऑल्सो. एंड one important aspect which I want to write here is nimbus. What is nimbus? Name given to rain bearing clouds. Name given to जिन क्लाउड से बारिश होती है उनको क्या बोलते हैं? उनको हम निम्बस बोलते हैं. इज एवरीवन क्लियर अबाउट दिस? इज एवरीवन क्लियर अबाउट दिस? नाउ वी आर गोइंग टू ड्रॉ दैट. ये भाई कौन से क्लाउड्स, क्या उनकी रेंज, क्या उनके टाइप्स, ये आपको एग्जाम में भी बनाना है. अगर जरूरत पड़ी तो इधर क्या आएगा, हाइट आएगी 1 2 किलोमीटर्स, 4 किलोमीटर्स, 6 kilometers. Okay, so these are strato, mid, high clouds. Get that? And we'll make their shapes. So quickly everyone draw this graph and let's see how this came into existence, how the book ones are making it like this. So ये जो क्लाउड का फॉर्मेशन है, आई वुड वांट एवरीवन टू for a minute take the names of all these clouds, and then we'll understand that how these categorizations have happened. Quickly everyone. High clouds, middle clouds and low clouds. Stratus, you can use those words. And we'll head cumulonimbus quickly. Done? Let's look at these clouds. So सबसे ऊपर you will see the word cirrus. Cirro, filamentous, almost transparent cirrus. Cirrus, which is like this cabbage, cauliflower shape, that is called cumulus. So cirro with cumulus makes it cirrocumulus, and cirrus with layers is called cirrostratus. In the upper atmospheric clouds, these clouds are mostly made up of ice. So ऊपर के clouds क्या है? Mostly made up of ice. And certain phenomena like if you see the sun and you see a glow around it, or the moon and a glow around it, mild glow, and sun also when it is under the clouds, because you cannot see the sun just by looking at it because the glare is there. But if the sun is low, when we are looking at nowadays, because of the hazy conditions in the afternoon, you can have a look at the sun, yes or no? तो सन आज दिन में भी देख सकते हैं आप, बिकॉज ऑफ दैट्स व्हाट आई एम सेइंग, बिकॉज ऑफ द हेज. सो उस केस में व्हेन यू सी दिस हैलो, इट इज नॉट एनीथिंग एल्स बट द सीरोस्ट्रेटस कमिंग इन बिटवीन यू. इज एवरीवन ओके? अब हम आ गए मिडिल में. मिडिल में यू विल सी ऑल्टो ऑल्टो, ऑल्टो क्यूमुलस, ऑल्टो स्ट्रेटस, ऑल्टो क्यूमुलस, ऑल्टो स्ट्रेटस, and yes, cumulus will also be there. So cumulus is here. Now as we are coming down, stratus and stratocumulus. The stratocirrus क्यों नहीं है? Cirrus is always on top. Cirrus is always on top. So alto is the middle one. Cumulus we have already looked at. Stratus we have looked at, and then we have stratocumulus. Stratocumulus is here, and the one which crosses all the barriers is called the cumulonimbus. Is everyone okay? इसको बनाएंगे कैसे? So पहले तो यहां पर 3 क्लाउड बनाते हैं. Let's make 3 clouds. Very simple. Our first cloud is going to be a layered cloud, and we will call it stratus. We'll call it stratus. The code is ST. Then we will make cumulus. The code is CU. And here the thin filamentous ones, these thin strands, we call them the cirrus. So 3 clouds, easy to remember. Then we'll start making combinations out of them. If I have cumulus in the higher levels, these cauliflower shaped, cotton ball shaped ones in the higher levels, so cirrus bhi hai, cumulus bhi hai, we call it cirrocumulus. And if we have these strands coming like this, long strands which we were talking of, so this is again cirrus, but it is layered cirro and stratus. These are all icy clouds. No precipitation. They do not give precipitation. And if you wish, you can make a sun also here and some glow about that. So that's called a halo. So that's your first thing which we talked about. So पहले 3 cloud बनाने, 1, 2, 3, and then the variants of that. Now we are already here. In cumulus you will find 2 variants. Cumulus में alto आ जाएगा. Alto cumulus, alto stereo, because the word alto means middle, cirro means high. So cirro cumulus, high will be cirro. Cirrostratus. Cirrostratus. Here what I am going to get is, I am going to get alto cumulus. So what is the difference between alto and cirrocumulus? The height. Alto means middle, cirro means up. Also, Zero will be ice. Alto may have water in it. Alto may have water in it. Now I have layers. I am in the middle and I have multiple layers. And these are watery layers also. So what will this be called as? Alto stratus. Yes or no? Now we are coming to stratus. Stratus के लिए यहां पर तो word है alto. I have a word here for low cloud. I have something called as strato. Now strato से पहले stratus आ चुका है. Stratus has come. Only thing is that I can get cumulus at this layer. These are called stratocumulus. Is everyone okay? Alto, strato, cirro. So how many cloud types do I see? 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Now I want rain to happen. Rain to happen, everyone, please pay attention. Rain will happen only in case of low and mid. So low में क्या आता है? Strato. तो strato will give me rain. Strato will give me rain, and cumulus will also give me rain. But what will not give me rain? What will not give me rain? The cirro will not. So this is your rain bearing stratus cloud. We call it nimbostratus. क्या बोलेंगे इसको? निम्बो स्ट्रेटस. इसको क्या बोलेंगे? क्यूमिलो nimbus. This cloud has vertical rise. This is also called the thunder lightning and storm cloud. And this does not have just one layer, this goes across layers. This is where heavy rain also hail comes from these clouds. These are your cumulonimbus clouds, C-U-N-I. This is nimbostratus. Is everyone okay? So 10 clouds in all. 10 clouds in all. That is what you have to keep in mind. Is everyone with me on this? 10 clouds. 10 तरह के क्लाउड हैं जो हमें पता होने चाहिए. Is everyone okay with this? Cloud type, cloud के बारे में बता दिया. Super, I told you about super cool also. I told you about other things also. और ये क्या है? Base of the cloud. Base of the cloud is at different altitude. Sir, how do we count this? ये generally base of the cloud को देखा जाता है कि कहाँ पर है. Is everyone okay with this? Everyone clear? Cloud classification. Now I have a question. Next question. process of precipitation. We're talking about we're talking about clouds are formed. For clouds to form, we need the air to cool down. Air must cool down, reach its saturation. In fact, even before saturation, the moisture should start condensing. And the moisture condenses, for that it requires cooling as well as hygroscopic nuclei. But this whole thing which I have told you till now is a process of formation of cloud. It is not the formation of precipitation. This is how a cloud droplet is created. This is how a cloud droplet is created. Imagine. And cloud droplet is a very tiny thing. It's a very, very tiny thing. Very tiny thing. And in that cloud droplet, I told you how much? 10 micrometer. अब कितना है ड्रिजल इज 0.05 मिलीमीटर. अगर उसको माइक्रो में करोगे ना तो यू रिक्वायर एटलीस्ट 500 to 5000 500 to 5000 माइक्रोमीटर. तो आपको एटलीस्ट 1000 cloud droplets will combine to form the tiniest of the mist drop. एंड अगर आपको वाटर ड्रॉपलेट बनाना है तो वाटर ड्रॉपलेट विल टेक मिलियंस ऑफ क्लाउड ड्रॉपलेट्स. डू यू गेट दैट? सो precipitation is actually the drop falling down. But what we have created till now is, what we have created in the atmosphere is a cloud. अभी तक क्या बनाया है? Cloud. And what does a cloud have? Everyone, can you tell me what does a cloud have? What does a cloud have? Cloud has what is this? Water vapor. Cloud has cloud droplet, and cloud has a few ice crystals. Is everyone okay? क्लाउड के पास क्या है? कोमल इज सेइंग वाटर ड्रॉपलेट एंड आइस क्रिस्टल. तीन चीजें डाली. वाटर वेपर भी तो होगा. सो हाउ कैन वाटर वेपर बी देयर? वाटर वेपर विच इज नॉट येट कंडेंस्ड. सो कैन आई से अनकंडेंस्ड? जिन लोग को समझ में नहीं आया, uncondensed water vapor. Is it possible or not? Is it possible or not? Yes. Now cloud is there. Cloud has been created, but it is not creating rain. बारिश नहीं हो रही. Cloud तो समझ में आ गया. All that I have taught you has given me these three things. And they all are very light. They all are very light. They have a tendency to stay suspended. Billions of these droplets and everything is there. They are in the cloud. Uncondensed water vapor is there, cloud droplets are there, ice crystals are there, very few ice crystals are there, and I am looking at the cloud, but the cloud is not causing rain to happen. So ये बारिश क्यों नहीं हो रही है? And have you observed that the rain does not happen very often? So how will rain happen? जल्दी बताओ, बारिश होगी कैसे? Clouds are there. Clouds are light and easy, and when wind comes, it blows with them. So how will precipitation happen? The exact process or processes are not completely understood. हमें पता नहीं, थोड़ा बहुत पता है, little bit. And we've understood that we can even create a cloud. Cloud, आपने सुना artificial rain. Have you heard of something called as artificial rain? Even artificial rain does not mean that you want rain to happen at this point, at this time. No. No, 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 no. It is about you creating a cloud. You creating a cloud, and that cloud may rain, may not rain. So, post World War II, two accepted theories came forward. Number one is there is this Norwegian uh, Norwegian meteorologist Bergeron, Tor Bergeron. बर्जेरॉन का क्या है, बर्जेरॉन का आइस क्रिस्टल थ्योरी. एंड सेकेंड इज, ये ऑस्ट्रेलियन है, बोवेन का. बोवेन का व्हाट डू वी कॉल इट, कोलिजन कोएलिसेंस थ्योरी. ठीक है, दो थ्योरी. Which theory came first? Bergeron theory came first in 1933. 1933 came first. Yes, and this came in 1940s. Two accepted. अब आप कहोगे सर ये तो वर्ल्ड वॉर अभी खत्म नहीं हुआ था 1933. Around that, post World War II, these theories are accepted. Let us understand the Bergeron theory. Are you interested in knowing that? अभी तक यूपीएससी ने कोई क्वेश्चन नहीं पूछा है. अभी तक यूपीएससी hasn't asked a question on Bergeron or collision coalescence, but anyone who's trying to understand precipitation must know and understand this. So that is what we are talking about. Is everyone okay? तो Bergeron theory, Tor Bergeron from Norway, yes, gave his theory based on his study of properties of water and the forms or the states it takes. Okay. The first property which he observed was water droplets in a cloud. They do not freeze. Water droplets. So, पहले एक प्रॉपर्टी इसका देखते हैं. First is water doesn't freeze. Water droplet कर दें. Do not freeze below or at So our understanding is that when it comes 0 degree Celsius, water must freeze. Yes or no? Water must freeze. But he says that it is not going to freeze at 0. water droplet do not freeze at 0. First, if suitable freezing nuclei are missing. So पानी है, क्लाउड में क्या है, क्लाउड में वाटर वेपर है, वाटर वेपर है, क्लाउड में वाटर ड्रॉपलेट है, एंड क्लाउड में आइस क्रिस्टल है, बट आइस क्रिस्टल आर वेरी वेरी फ्यू. Why? Because suitable freezing nuclei are missing. If suitable freezing nuclei, water can stay super cooled liquid till minus 40 degrees Celsius. Till minus 40 degrees Celsius, water can stay this thing super cooled. Yes. Freezing nuclei become active below minus 25 degrees Celsius are very sparse. तो freezing nuclei अपने पास है नहीं. We don't have freezing nuclei. We have a cloud which has super cooled water droplets. Yes. So what is this cloud? Everyone, shall I make this cloud? Once again, एक बार फिर से बना दूं. Cloud है. At what temperature is it? At what temperature is it? Say for example, the temperature is minus 15 डिग्री सेल्सियस. क्लाउड का टेम्परेचर कितना है? minus 15 degree Celsius. What does the cloud have? What does it have? What does it have? Drops, no, moisture. It has water droplets. And it has a few ice crystal, very, very few. Is everyone okay? So water is there, water is there, water vapor is there, and ice crystals are there. Three things are there. What does it have? So what does it have? Cloud has water vapor, water droplet, and ice crystal at same temperature. Okay. So the temperature is everyone, temperature is minus 15 degrees Celsius. What does the water vapor want to do? What does the water vapor want to do? Abhinav is saying wants to freeze. What does the water vapor want to do? Abhinav is saying it wants to freeze. सिर्फ water vapor. Manish is saying it wants to condense. जल्दी बताओ क्या करना चाहता है. अगर मैं मनीष की बात बोलूं तो मनीष बोला कंडेंस करना चाहता है. एंड अभिनव इज सेइंग फ्रीज करना चाहता है. क्या करना चाहता है? प्लीज टेल मी. फ्रीज और कंडेंस? फ्रीज या कंडेंस, दोनों कर सकता है ना. टेम्परेचर तो -15 है. टेम्परेचर इज -15, यस और नो. फ्रीज और कंडेंस. Wants to condense, wants to freeze. Can I say, just like boiling was a change of state. In this, you want to become liquid. In this, you want to become solid. Yes or no? Can I say it will create a pressure called vapor pressure? Vapor pressure. होगा कि नहीं होगा? Remember, when we boil a thing, heat a thing, vapor pressure increases and it wants to go out. In this case, the vapor pressure is very low. The vapor pressure is low, but the vapor pressure is low for both the things. Water droplet के लिए भी है, इसके लिए भी है. Tell me, even the water droplet wants to freeze or not further? Yes or no? Can I say both water droplet and ice crystal, both water droplet and ice crystal are experiencing pressure from the vapor? Yes, vapor wants to condense also, vapor wants to freeze also. Vapor wants to condense also and vapor wants to freeze also. किस पे ज्यादा प्रेशर है? Who's getting more pressure? Is the droplet feeling more pressure or is the crystal feeling more pressure? Is everyone okay? There is vapor. There is vapor. Vapor is exerting pressure. Vapor wants to become liquid also. Vapor wants to become solid also, because the temperature is so low that it is not just condensation point, it has come to the freezing point. So vapor तो दोनों चीजें चाहता है. Vapor पहले ये बनेगा और फिर ये बनेगा. Even the droplet wants to become here. True or not? So Bergeron looked at another property of water vapor, that over ice, please write down, over ice, the saturation vapor pressure is lower than what is over water. Over ice, vapor pressure is lower than what is over water. Saturation vapor pressure. Saturation vapor pressure means the vapor pressure at which vapor will turn into ice. At which the vapor will turn into ice. Is everyone okay? So ice पे वो saturation vapor pressure lower है. Do we get that? So the pressure so if the vapor pressure on, or if the air is saturated with respect to water, that means RH is equal to 100%, then the same air is ice. We'll fill up the blank. Everyone pay attention. So we are looking at saturation vapor pressure. Remember the boiling vapor pressure? Boiling vapor pressure is the pressure at which the water will turn into, everyone stop looking at what we have written. Listen to me. ये तो हमने लिखवा दिया. We are trying to understand something very important over here. Everyone, please pay attention. Uh, for boiling to happen, what should happen? The vapor pressure should exceed the outer pressure. Yes or no? The vapor pressure should exceed it. For condensation to happen, the vapor pressure should be very low. Yes or no? Very low. Do we get that? When was the vapor pressure equal to atmosphere pressure? What temperature was it called? When vapor pressure was equal to atmospheric pressure, when we were heating, what was that temperature called as? Everyone, what was that temperature called as? What was that point called as? When vapor pressure was equal to the atmospheric pressure. When the balance was there, I was heating it. The vapor pressure, because of heating, became equal to atmospheric pressure, and the air started to turn into this thing. कहाँ गया वो? लिखवाया था कहीं पर, जो लोग भूल गए अचानक. When vapor pressure is equal to atmospheric pressure, what do we call it? Boiling point. Yes. Now everyone, instead of increasing the vapor pressure, we are reducing the vapor pressure. And when there is no vapor pressure left to boil, what will happen? Opposite of boiling. What is opposite of boiling? What is opposite of boiling? If this is the evaporation, what is opposite of evaporation, everyone? What is opposite of evaporation? What is opposite of evaporation? So condensation. Yes, evaporation is changing water into air, into gas. Now we are doing the opposite of it. We are cooling it. Gas is going to come back to this. So gas is coming back to liquid. Yes, at all temperature. But a point will come when no gas wants to become liquid, or no gas wants to become stay gas. All of it wants to turn to liquid. That point is called saturation point. Do we get that? All water wants to go into gas is boiling point. Yes. All gas wants to come into water is saturation point. Is everyone okay? All gas wants to go into air, all water wants to turn into vapor, boiling point. All vapor turned into water, no more wants to go into vapor, that is saturation point. Can I call that saturation point means RH is equal to 100%, no more vapor pressure? Is everyone okay? Do we get that? So that saturation pressure, say for example, everyone, is the boiling point of water same as the boiling point of say for example alcohol? Are they having the same temperature? Does boiling point differ from liquid to liquid? Does boiling point differ from liquid to liquid? If I leave petrol in the room, will it turn into vapor even without me heating it? Yes or no? So boiling point changes. Can I say the saturation point also changes from liquid to liquid? Do we get that? Saturation point also changes from liquid to liquid. Now tell me, whose boiling point is more, water or petrol? Whose boiling point is more, water or petrol? Water or petrol? Hardik is saying can't find the Telegram group. Hardik, we don't have a Telegram group now. We have closed that. Yes. Everyone, please tell me which one has a greater boiling point, water or petrol? You are saying water. Yes, everyone. So imagine if I heat petrol, yes, to the temperature of boiling point of water, will the petrol already have disappeared by the time it reaches the boiling point? Yes or no? Yes or no? True. सर पेट्रोल को उतना गर्म थोड़ी करना, वो तो खुद ही जाने को तैयार है. True. So can I say water will need more heat to turn into vapor? Petrol will not need that. Similarly, everyone, to turn into liquid, some liquids will have a different saturation pressure. Some liquids will require more vapor, and some liquids will require less vapor. Some liquids will require less vapor, some liquids will require more vapor. Do we get that? Is everyone okay? So water and ice out of water and ice, it is seen that ice require less vapor. Ice less vapor पर भी वेपर को आइस में टर्न कर देगा, बट वाटर विल रिक्वायर मोर वेपर. इज एवरीवन ओके? आई डिड नॉट अंडरस्टैंड दिस, तो मैंने इसको टेक्निकल लैंग्वेज में लिखा. टेक्निकल लैंग्वेज में लिखा है मैंने कि ओवर आइस द सैचुरेशन प्रेशर इज लोअर देन ओवर वाटर. आइस में कम वेपर होगा तब भी आइस सैचुरेट हो जाएगी. आइस विल रीच सैचुरेशन पॉइंट एंड वेपर विल इमीडिएटली टर्न इनटू आइस. Vapor will immediately turn into ice, but water will require more vapor. Do we get that? Over ice, saturation vapor pressure is lower. कम vapor में भी ice बन जाएगा वो, because इतना ठंडा है, because we are almost at supercooled levels. Is everyone okay? So water will require more vapor, but ice will require less vapor. Now everyone tell me, अगर water ही saturate हो गया, if air is saturated with respect to water, what will be the state with respect to ice? आइस के केस में तो आइस तो बहुत पहले ही सैचुरेट हो गया होगा. रिमेंबर, आइस रिक्वायर्स लेस प्रेशर, नो? सो आइस से तो पहले ही सैचुरेट हो गया होगा, जस्ट लाइक पेट्रोल वुड हैव इवेपोरेटेड अर्लियर. कैन आई से इट विल बी सुपर सैचुरेटेड? ट्रू और नॉट? और इसको क्या फील हो रहा होगा? Did everyone get that? So पहले तो ये साइंस है, थोड़ा सा साइंस समझाना था इसलिए लिखा है कि वाटर ड्रॉपलेट वांट्स टू टर्न इनटू आइदर लिक्विड और सॉलिड. वो पहले प्रेफरेंस क्या होगा? इट विल बिकम सैचुरेटेड ओवर आइस. वो पहले आइस बन जाएगी, पहले ही आइस बन जाएगी. बट अगर आइस नहीं बनी, यहां तक आ गया तो दैट इज देयर. इज एवरीवन विद मी ऑन दिस? Is everyone with me on this? नहीं है तो ये लिख लो पहले, फिर बताता हूं. Then I'll explain the Torr-Bergeron process. Torr-Bergeron process. What is this? Everyone, what are these? Vapor. What is this? Cloud droplet. Cloud droplet. Do we get that? And what is this? Ice crystal. There are very few. Everyone okay with this? Bergeron process को समझने की कोशिश कर रहे हैं. Ice crystal. Temperature 0 degree Celsius. RH is equal to 100% for water, 100 for ice. दोनों को 100 लग रहा है. Is everyone okay? Everyone, did you understand the situation? This cloud is at 0 degree Celsius. RH is equal to 100 for water. RH is equal to 100 for ice. So why they are same? Because just now freezing point has come. Just now freezing point touched. Freezing point has been touched. Freezing point has been touched. Both the water can turn into water, vapor can turn into water also, ice also. What is the tendency? Same. Tendency is the same. Now what happens is, Further cooling. Further cooling. Yes or no? Temperature has become minus 10 degrees Celsius now. Minus 10 degrees Celsius. Now the temperature has gone into supercooled. In supercooled, remember RH over water, वो तो एक बार 100% हो गया, 100% ही रहेगा. But RH on ice now has become 110%. Because remember, as water cools below the 0 degree freezing point, it will not freeze. There are no nuclei over there, and the vapor pressure has changed because the temperature is cooling. Yes or no? But remember, ice has a lower saturation vapor pressure. So ice को क्या लग रहा है? Strong feeling that this vapor should turn into ice. Yes or no? Is everyone okay with 10 degrees Celsius? Why did we write that वो उधर बढ़ गया? Because over ice the saturation vapor pressure is lower than what it is over water. So water को तो अभी 100 ही लग रहा है. Water तो वो है, लेकिन इसको ज्यादा लग रहा है क्योंकि ये तो पहले ही हो जाता saturate. Is everyone okay? Now you are a vapor droplet. You are a vapor droplet. Who is pulling you strongly? Who is pulling you strongly? What is this? This is a saturated cloud. Who is pulling you strongly? You are a vapor droplet. Who is pulling you strongly? Sir, ice is super saturated. उसको बहुत ज़्यादा pressure है. Ice says, भाई, I cannot take this. Yes? So what will happen to the vapor? What will happen to the excess vapor? It can turn into water also, it can turn into ice also. But who is pulling it more? Yes? So what will happen to this ice crystal? What will happen to this ice crystal? So this ice crystal will grow bigger. Grow bigger. Yes or no? Ice is pulling strongly, so you are a vapor particle because ice has become super saturated. Now tell me everyone, if I take away the vapor from the cloud, will the cloud still remain saturated? Will the cloud still remain saturated? Now, RH of water will be 90%. Why, sir? See, all the droplets were exerting pressure on the water drop. How much was the pressure? 100%. Now you removed the drops, no? If the drops are removed, is the water drop feeling saturated or unsaturated? अभी तक तो वेपर का प्रेशर था ना, वेपर का प्रेशर was 100%. Now you remove the vapor. Is the water droplet feeling unsaturated or not? Is the water droplet feeling unsaturated or not? इससे क्या हुआ? RH ice तो 100 हो गया. RH ice became 100. But this one has fallen down. दोनों ही नीचे आ गया. 110 से वो आ गया. अब तो unsaturated हो गया. Remember, in unsaturated, condensation happens. No. This will want to make it saturated. So what will happen? The drop will start evaporating. Drop will evaporate and give birth to what? Drop will give birth to vapor. Drop will start giving birth to, every drop will start breaking now and it will give birth to vapor. Is everyone okay? So who is growing in size? In this round, first round, who grew in size? Ice grew in size. Ice crystal became bigger. Who became smaller? The water droplet became smaller. some of them turn totally into vapor. Water droplet has turned into vapor. Is everyone okay? So the amount of vapor will remain constant. Who is growing in size? Ice crystal will grow in size. Who will die? कौन कुर्बानी दे रहा है? Cloud droplet. Yes or no? Up to what point the cloud droplet will turn to vapor? Till this situation comes, sir. RH is equal to 100 कर देगा ये फिर से. Moment it makes RH equal to 100 for water, what does ice feel? Ice पे pressure आ गया. Ice feels यार ये तो 110 है. What will ice do? It will eat more. So what will happen? These crystals, everyone, will become bigger. Yes? Bergeron says, in the Bergeron process, the limited or sparse ice crystals in the cloud grow in size at the cost of cloud droplet. At the cost of cloud droplet. These crystals grow too big and then break into multiple smaller ice crystals. Yes, newly formed ice crystals accelerate the whole Bergeron process, and soon entire cloud has ice crystals. Ice crystals are heavier than cloud drops, and when they are big enough, they start falling down to give precipitation in form of snow or rain or drizzle. The process is finished. Is everyone okay? ये Bergeron process है. The drops will keep on evaporating. Ice crystals will keep on becoming bigger. When they are large enough, they will break. They will give birth to many new ice crystals. This whole process gets accelerated. A full chain reaction is created. Yes? Like a chain reaction. Now you have crystals in the cloud, and these crystals are big and heavy. They will start falling down. If they are falling in Canada, already the atmospheric temperature is -5 degrees Celsius. These crystals will come down as snow. But if they are falling in warmer atmosphere, as the crystals are falling down, they will melt and they will turn into drops. So either you will get snow or drizzle or rain. Did you understand the Bergeron process? He says this happens in the temperate regions where high clouds are there. Remember, high clouds are made up of ice. High clouds, the cirrus and all. So those very, very cold climates, very, very cold climates, I just need a few ice crystals, and those ice crystals will multiply, multiply, multiply at the cost of the water drops, and they will give me rain. Is everyone okay? This whole process is called the Bergeron process. 1930s में दिया गया. So this is increasing at the cost of that one. If you did not understand, एक बार फिर से इसको पढ़ना. Vapor pressure was a technical area. Do we get that? A problem ही आ गई with Bergeron. There was a problem. Problem was, where did these ice crystals come from? So Bergeron said that the top of the clouds, the higher clouds, yes, cirrus part, that is very cold. So when you are in minus temperatures, then you always have such ice crystals. So there were scholars who said that's okay. Mr. Bergeron was from Norway. In Norway, the clouds may have that temperature. But when we are talking about Sri Lanka, India, equatorial region, there are times when the atmosphere is giving rain and the clouds are probably 8 to 10 degrees Celsius. They don't even go below 0 degrees Celsius. They don't even go below 0 degrees Celsius. Then how would the crystals form? Where would the ice come? So Abhay is asking, if crystal nahi hai, to precipitation nahi hoga. Yes, Abhay, not only you, the scientists are also asking. That we understand Bergeron, he is scientifically absolutely correct. He is correct. He's got very good idea. Everything is good, a chain reaction. But if the crystals are not there, and crystals, for crystals to form, what do we need? We need a temperature which is sub-zero. Yes, it should be below freezing point. So in the tropical latitudes, because remember, the tropopause is 18 kilometers, convection happens. So rain happens even from the low clouds. आपके 2-3 किलोमीटर की हाइट पे जो क्लाउड है उससे बारिश हो गई. The cloud is causing rain, but the cloud itself is not at a temperature which is sub-zero. How will that happen? So people looked at Bergeron process. They said, we have understood it, but there must be something else. And that led to the Australian meteorologist, Mr. Bowen, to give us another theory, which is called the collision coalescence theory. That theory I cannot talk today because I have another class to catch. So I'll catch you day after tomorrow. Is everyone with me on this? पढ़ेंगे इसको? Everyone, just one topic from either Savindra Singh or D.S. Lal or whatever book you have. Process of precipitation. Bergeron collision coalescence. Collision coalescence is very, very easy. वो छोटी छोटी बूंदें आपस में टकराएंगी, स्मॉलर बूंदें आपस में टकराती है बिकॉज दे हैव डिफरेंट वेलोसिटीज, टकरा के बड़ी हो जाती हैं. They become so big in size that they become heavy, they fall down. वो तो बहुत ही लड्डू वाला है. So there is hardly anything in that. But yeah, this was technical. And if you were listening to me and you were with me, thoda bahut you trusted me with the ideas of vapor pressure and all. I know in even my own school days, I hated this idea of gas laws and vapor pressures. So I tried to bring it as easy as possible for you. If you have some doubt, please watch the video again. I'll see you day after tomorrow. Have a great day. Take good care of your health. Particularly avoid going out in the polluted air without any mask on. Jai Hind.